Hello, welcome to another video of heuristic algorithms. In this video I'm going to explain the code that I use for the randomized greedy algorithm for the flow shop with two stations. And I'm not going to start from the top. I'm going to start from in the sequence that it's probably the easiest to understand and building from there. I have a supersedure here that just prints the array, and that is, once I have computed the array, I can send it to Excel. This is something that you're familiar with. I am just passing the parameters. The parameters are A, the array, N and M are the dimensions of the array, the number of rows and columns, and the address is just what I'm going to print. And this is set up as a procedure because I'm going to do this again and again, and maybe I'm going to use it somewhere else. And just printing matrices is something that we're going to be using in this course over and over again. So for sure, having a procedure that prints an array in any particular cell in Excel, it's very convenient to have. The next is the decision on, or the procedure on how to switch the pairs. The parameters for this array, for this procedure, is the array, again the dimensions in the number of rows N and the number of columns M. And I'm also passing as parameters the total lateness and the number of jobs late. The first step that I do is I create a random number that is stored in R1. The random number has to be a number between 1 and 15, and for that purpose I compute a random number between 0 and 1. I multiply times 15. That is going to give me a number that is between 0 and 14, because the random number never reaches 1. It's always less than 1. And to that I add 1, so now I have a random numbers between 1 and less than 16. And then I compute the integer part of it, so pretty much it just truncates. It doesn't round up or down, it just truncates the decimal part. It just keeps the integer part, and I get a random position for the first row to be swapped. And then I do the procedure again for the second random number. But I need to make sure that the two random numbers that are selected are different, because swapping a position or a particular job with itself means I'm not getting any benefit. So I want to make sure that they are different, so I create a loop around doing the second random number with do and loop, and I repeat that process as long as R2 is equal to R1. If R2 is different from R1, then it's going to come out of the loop, and that's exactly what I want. I want just random numbers that are different in R1 and R2. Once I have that, what I need to do is I need to copy everything that I have in one row to the other row, and that is achieved with a 5-line code that is for all the columns. I keep storing each one of the columns for the first job, one column at a time, in an auxiliary variable, so I don't lose it. Then I update the value of that position in the array, and then I take the value with the other position in the array, and then I take the value that was stored in the auxiliary variable and store it in where it needs to go. So effectively swapping the two contents. And I do that for all the columns, particularly in specifically just for swapping the rows R1 and R2. Then I generate an auxiliary variable to compute the total lateness, because I want to compare how much it was the total lateness before the change. And then I reset the total lateness and I execute the procedure to compute the times, or the complete table. And that's a procedure in which I'm going to describe later on, but the parameters are the same. The array, the dimensions of the array, the total late, and the total number of the total lateness, and the total number of jobs that are late. And after I compute that, I have updated the total lateness of the alternative solution, and I need to compare that with the previous solution. So I compare if the auxiliary late, that is the lateness that I had before the change, is less than the total lateness that I have right now, then I have to switch back, and I execute the change back. And this is probably not the most efficient way to compute it, because anyways I compute the algorithm again, the table again. It would be much more efficient if I take this part of the code that it's executed only if needed, because we switched back to the original position. So this would be a much more a faster way to execute the code. And if we do not change back, because the total new late is less than the auxiliary late, there is no need to compute again these, because we're going to keep that. And finally, we go to the main computational procedure. And here is the main computational procedure for calculating the table. We have that we are passing the same parameters: the array, the dimensions of the array, the total lateness, and the number of jobs late. We initialize the total lateness, and number of jobs late at 0, and then we initialize the columns that are supposed to be computed based on the data, depending on the sequence. Those are columns 7 to 12, and we initialize them with 0 to make sure that everything is clear. Then the next step is it looks like I am yeah, the first job is start at t equals 0. If it's not the first job, for all of the other jobs, it depends on when the previous job ended, and those are columns 7 and 8. Column 9 is when the first the second station is going to start, and that depends on when the previous job ended, but also could depend on what happened with the previous job. So what I do is initialize the value of the starting time of the second station, that's column 9, and then decide if I need to update that based on the fact that only for jobs that are larger than the first one in the position, I need to check or not the in station 1. So we compare the previous job at station 2 with this job at station 1. The largest of the two is kept, and so I update the starting time in case I need to, and the computations of the finish time in column number 10 only depends on the starting time in column number 9 and the processing time of station 2. I can update the tardiness. In case the tardiness is negative, I will consider it a 0. And the total number of if this job is late is going to depend on the fact that if the tardiness was larger than 1. Then we compute the total value for the tardiness by adding to the total and the total number of late jobs, and that's the main procedure. Finally, putting everything together, we have the main macro, and here I dimension the array, which 15 jobs and 12 columns, and I dimension the performance measure total lateness as an integer, and I dimension the arrays with a redeem at n by m, and I read the values from the initial position that describe the few values, and I actually load everything on the performance, although it would have been enough just to load the first 6 columns. I load all of them, and then I start with the first computation for the array to make sure that everything is as it should be, and I print it out as a test, and then I write the performance measures again to make sure that everything is fine, and then I repeat for 1000 times, executing the switch of pairs and printing the array. And remember, when we switch the pairs, when we execute switching pairs calls the task to compute the whole process again. So we do that, and we print out the total value and the number of jobs, the total lateness and the number of jobs late, and that's the end of it. It's a very simple procedure. Just read and execute 1000 times the switching of pairs, the computation, and printing the array as we got it. In theory, the only reason why I'm printing this array here is for you to see its progress, but we can improve the speed of the algorithm by not having to print it until the very end. But for purposes of you seeing how this works, this is how I implement it.